Ah, the regressions, all sorts of regressions. I'm even gonna do the first one for you. Let's see, the table shows the operating cost of a small store from 2000 2005. Assume that T is the number of years since 2000 and C is the cost in thousands of dollars. Find the best fitting quadratic model for the data, round to 2 decimal places. So let's go through some stuff here just to make sure it's on. Let's turn diagnostics on so I can see the R value, the R squared value. So I hit second zero catalog. I'm gonna hit the alphanumeric D. You see it right there? That's gonna drop me straight down to the D's. Then I can just down arrow to diagnostic on. Enter, enter. And let's throw this stuff in. We're gonna go to stat. We're gonna go to edit. You're gonna put our X's into list 1 and our Y's into list 2. Time is, I can't think of a single example I've ever done where time was not X. So again, that's list 1 and list 2 on a table. List 1, list 2. All right, that's how you do it. List 1, list 2. X is in list 1, Y is in list 2. Let's see, so we have a 0, we have a 1, we have a 3, we have a 5, 14.8. Remember, if you don't have a TI-84, you can go to ti84calc.com, and there's a TI-84 there for you to use. All right, now they're suggesting a quadratic fit. I won't actually look at the stat plots. It does look like a quadratic model, me. Now, if you've never seen me turn on stat plots, I'll go through that process for you. And I have some stuff in Y1, Y2 I need to clear out. Because you didn't need to see any of that, now did you? So turn stat plots on, you hit second Y equal, you press enter, and you see where it says on right there and the type and stuff like that. Mine were already on though. So is it a quadratic? It kind of looks like a quadratic. I kind of see the beginning of a parabola. All right, it's there. All right, let's go to stat, calc, quad reg for quadratic regression. So if it is a quadratic, the R squared value should be very close to 1. And it is. It basically is 1. So it's a very good model. And, you know, just a refresher here, if you want to put that on your graph, stat calc, quad reg, we can put that regression equation into Y1 by hitting vars, yvars, function, Y1. And now when I do my zoom 9, I will see that curve and the attempt to fit it to those points. I kind of think it might be off on that one to the right, but no, it went right through it. So yeah, definitely looks like a parabola. Anywho, let's see here. I forgot to copy down my equation here. I don't like that the author of this test question wants you to round to the second decimal place, but they do. It's just the way it is. It's what they want. So we'll go with it. So we're gonna plug into that form up there. You can see the standard form ax squared plus bx plus c. If you don't get that, you probably have an F. We got y equals 0.95 x squared minus 6.67 x, and then plus 14.81. Now, I'm going to do two different ways. I've got a graph and a calculator, and I'm also going to do it by hand because I do want you to remember how to do things by hand. The lowest cost, in this case it's t, is at opposite b over 2a. So the time here, the time is at 6.67 divided by twice a 0.95. Now let's just see what that is. We'll just go ahead and keep rounding to 2 decimal places just like they're doing, even though it's rounded, but whatever. And what I want to do is I want to compare and contrast this answer with what a graph is going to get me. You'll notice I'm writing horizontally, so I got to use master parentheses and stuff like that to keep things correct. But it's around 3.51. Now that's the time, that's the year it happens. To actually figure out what the value is, I plug that back into my equation because it's the x value. So the cost y is 0.95, 3.51 quantity squared minus 6.67 times 3.51 plus, that's a bad looking one, 14.81. I just push some buttons at TI-84 and it'll tell me what the answer is. See, it's actually a negative 6.67. Ta-da! 3.1. This was the lowest cost, right? So roughly 3.1. Now that is in thousands, right? Thousands of dollars. So that would be $3,100. It's the lowest operating cost of this small store. Anyways, we had a graph in front of us because I spent some time doing that. A minimum is going to happen right here. That's called a legit minimum. So I'm going to hit second, trace, scroll down to 3. And it works by getting left. I already am left, so I pressed enter. Then getting right, so I'm just holding that right button for a while until I know I'm to the right of that minimum. Press enter, press enter. And you'll see here we got roughly 3.05 on the graph and 3.53 there because these are unrounded numbers. So if we got 3.05, well, that's $3,050. Now think about that. Anyways, the less you round, obviously, the more accurate you are. All right, I'm going to scan through and I'll be right back. You see what I want to do next. All right, so I'm going to do one of these on number 2. It says, determine if each table represents a linear, quadratic, or exponential function. Explain how you know. I know by looking at the scatter plot, because I have a rough idea what graph should look like, and R squared, which is called your variance. So those are the things I'm interested in. So let me do the one in the middle, and it says explain how you know too. So remember, we put our X's in list 1, we put our Y's in list 2. Don't be the dum-dum that hits the delete key. You got to use the clear key. And again, if you ain't got a TI-84, you go to ti84calc.com. And you'll have one. So I'm doing the one in the middle. All right, so let's see here. Let's look at the stat plot, the zoom 9, because I've got stat plots on. Still got something in y equals. Probably have a typo too. Let's clear that out. Let's check out my mistake. Looked like I had 3 wrong. I had a 1, probably a typo there. It's supposed to be a 14. So zoom 9 again. I would say that's probably exponential. Okay, so let's run through some things here. Just because you want to compare R squared. So let's do a linear regression. See what she looks like. She has an R squared value of 0.92. And not a bad linear correlation either, but she's not linear. Although it turns out it curved with whole perfect numbers. Interesting. And I wasn't expecting that. Let's do a quadratic, but the R squared value was kind of low. It was 0.9. R squared is 1 on a quadratic. So as much as I want this thing to be exponential, it's probably actually a quadratic because that's a perfect R squared value. And let's do an exponential regression and see what she says. Yeah, so there we go. This is definitely a quadratic. It had the highest R squared value. Now remember, R squared is variance value. Anyways, that's just what you need to do with these things. See which one has the best R squared variance. Or some of them, you look at them and you think numbers, you know. Anyways, I'll let y'all figure that out. Let's see, a student who waits at tables. I don't want to do that one. Let's jump to 6. 6 is a power regression. The table below shows results of an experiment involving the growth of bacteria. Write a power regression equation for this set of data, rounding all values 3 decimal places. Using this equation, predict the bacteria's growth after 15 minutes. Now, you'll even notice, like they told you, time was X and bacteria was Y. Like, you can't screw this up. I say that you can, obviously, but you shouldn't screw this up, right? And yet you will. All right, so we go stat, we go to edit. I'm talking smack. I'll probably make a mistake. Let's clear all this out. It's X is in list 1, Y is in list 2, children. I always like to look at the scatter plot. A power regression, definitely exponential and power regressions, they look about the same. They really do. But they want us to explicitly run a power regression. So stat, calc, power regression. You have to scroll a little bit for that one. There's exponential, there's power. Now I am going to go ahead and store the regression equation, vars, y vars, function y1, because I'm going to use that. So look at that R squared value, like ridiculously close to 1. This is probably the right equation. The reason I'm going to do that is because, I want to talk about the effect rounding can have, because it's a big deal. So anywho, here's my equation. My equation is y equals, how do they want us? 3 decimal places, 2.001. We have an x. That x value is 2.298. And then it's raised to some b value. Oh, I did that backwards. Forgive me. Here's the x, and it's raised to the 2.298. I'm thinking exponential. Now, I want to know what happens in 15 minutes, so I'm just going to feed this thing a 1. Go over to my trusty TI-84, push some buttons, right? That's how it works. 2.001 times a 15 rooftop to the 2.298. So 1009.03, which we're going to say is 1010. This is a life form. Always round up again. Always round life forms to the next whole number, not down. Never round life forms down. So let's see what my TI-84 says with the exact calc. So if you'll remember, I stored the equation into Y1. And if my grid goes out 15 units, I can actually just use second trace value. So I'm going to adjust my window to go out 20 minutes. All right. So now it looks 20 minutes into the future. And I'm going to hit second, maybe second trace value. I'm going to let the time be 15. And it didn't end up being that much different. But I think if you went in farther in the future, like 40 minutes, I think you would have started seeing a difference between the two for rounding purposes. But you end up with the same thing. One of them just a little quicker way of doing it than the other. All right, the coming table, sure don't want to do that one. Probably just do some matrices next. So I will pause real quick, be right back, need a break. All right, so let me refresh you on number 8, and hopefully you can figure out number 9. we're going to write an augmented matrix that contains only the coefficients of the variables. And that's called an augmented matrix. Now we're going to do something in our calculator called reduced row echelon form. So first we're going to throw this into a matrix. It is a 3 by 4. It has 3 rows, 4 columns. We're going to throw that in our TI-84. Hopefully you remember how to do this. Maybe you don't. I don't know. I know that the matrix tests were just bleh. That's about all I can use to describe them. So I scroll over to edit. And I just type in my coefficients here. Easy peasy lemon squeezy, making sure I don't have any typos. Now I'm going to quit out. We're always good at quitting. Second matrix, scroll on over to math. Remember, you're looking for something that's 2 below something here. There she is. Second matrix, it was all done in A. Bam, enter key. Wonder if I have a typo somewhere. I was not expecting that. So let me check my numbers here. Second matrix, edit. Wasn't expecting decimals. 3, -2, 1, -7, 1, 1, -2, 12. That's supposed to be a 3, isn't it? There it is. 3, 1, -1, 10. All right, so rerun that command again, or function, I should say. And there you go. And now you interpret. This is my result. And I just have to interpret it. The top row says x is 1. The second row says y is 3. The last row says z is -4. Written more affectionately as the order triple 1, 3, -4. Now, when you do number 9, your job is going to be to write a system of equations and then use matrices. For some of you, you'll just write answers and be like, I am a genius, Milbrath. I didn't need to do any work. Then I won't give you any credit for it. All right, solve the system using the inverse method. Okay, the inverse method. The inverse method uses the idea of inverses being opposites to come up with an answer. This is about x, y, and z. If you took a matrix that had x, y, and z and multiplied it by the inverse, this matrix times some matrix x, y, z, notice that 0 there because there's no y, would be equal to 7, 1, -2. That's how this works. Now, since there's no such thing as division of matrices, it turns out that this matrix XYZ is equal to this matrix times the inverse of this one. And order matters. Order matters a great deal. This is a 3 by 3. This is a 3 by 1. So this one has to go first. So I'm going to take a 3 by 3 multiplied by 3 by 1. I'm going to take the inverse of that matrix and then multiply it by this one. And you need to be showing me this stuff, okay? So let's get both of these thrown in my TI-84. We're going to go to stat, sorry, not stat, you can tell where I've been. Second matrix, edit, and A is a 3 by 3. 1, 2, 3, 1, 1, 1, 1, 0, because there's no y, is -2. And we'll throw the other matrix into matrix B. B is just a 3 by 1. She has a 7, a 1, and a -2. And we're going to take the inverse of the first matrix. So we're going to highlight that matrix, take its inverse, press that inverse key, and then I'm going to multiply it by the second matrix, B, and I should get some answers. And I did. I got 3, 6, 11. And this is the technique that I was actually taught as a kid. I don't remember being taught reduced row echelon form. You can just kind of line up there. X is 3, Y is 6, Z is 11, because that's the lineup process. And that's how much of your homework I'm doing. You're welcome for this. You are. You should say thank you more often.